colossal planet-killer asteroid sparked mega-tsunami on Mars, and now we know where it landed. Planetary scientists pinpointed the likely location of a massive asteroid impact that triggered an enormous tsunami on the red planet around 3.4 billion years ago. A newly discovered impact crater on Mars was likely left by an enormous asteroid that impacted the red planet 3.4 billion years ago and may have triggered an 800-foot-tall mega-tsunami. The colossal explosion, similar to the asteroid impact on Earth that wiped out the non-avian dinosaurs, the new study shows. From about 3.5 billion to 3 billion years ago, Mars was covered by vast, shallow oceans. During that time, one of these oceans, which once covered Mars' northern lowlands, Vastitas Borealis, experienced multiple mega-tsunamis when asteroids slammed into the ancient body of water, according to NASA. Past research found evidence of at least two massive wave events on the ancient shoreline that once surrounded the long-lost ocean, including large chunks of debris that washed ashore and rock markings that likely carved out as displaced water slowly drained back into the ocean. The first event likely occurred 3.4 billion years ago, and the second likely emerged around 3 billion years ago as Mars' oceans began to dry up, according to NASA. In a new study, published December 1st in the journal Scientific Reports, planetary scientists identified the new impact crater named Pohl, P-O-H-L, which is a highly plausible candidate for the first of the mega-tsunamis. Pohl is around 68 miles wide and lies around 394 feet beneath the suspected sea level at that time. The massive impact structure is also surrounded by 3.4 billion-year-old rocks. Based on the size of Pohl, research estimates that the asteroid responsible for birthing the crater spanned somewhere between 1.9 to 5.6 miles and released up to 13 million megatons of TNT energy. For context, the most powerful nuclear bomb ever detonated on Earth, the Tsar Bomba, released about 50 megatons of TNT energy. So this one was about 13 millions on Mars. Now the study team then used computer simulations to recreate the massive wave that would have been generated by this colossal impact. They found that the waves could have reached up to 820 feet tall and traveled around 932 miles away from the crater. These waves would have been large enough to leave behind the geological evidence already uncovered by past researchers, the team said. This gargantuan impact structure has some key similarities to the Chicxulub crater, which was left by the asteroid impact that triggered the massive extinction around 66 million years ago and wiped out the non-avian dinosaurs, the researchers wrote. The Chicxulub crater of Yucatan, Mexico, the Yucatan, Mexico peninsula, is significantly larger than Pohl, spanning around 112 miles, and was birthed by a larger asteroid that was about 7.5 miles across. The Chicxulub asteroid also landed on top of an ancient ocean on Earth that was around 656 feet deep at the time. In October, a pair of unrelated studies found that the Yucatan Peninsula impact also triggered a mega-tsunami with mile-high waves and triggered a mega-earthquake that rocked the planet for months. This is not the first time that researchers have identified a potential impact crater for Martian mega-tsunamis. In 2019, a separate team of researchers proposed that the Lomonosov crater, which measures around 90 miles across, was left by an impactor that could have sparked a mega-tsunami. However, the Lomonosov crater has not been precisely dated, so it's unclear which mega-tsunami the impactor could have kick-started, or if the impact happened when oceans were present at all. This is by Harry Baker on Live Science. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.